Hello everyone, hi again, welcome back to another video. And in this video, we're going to solve a new problem, that is running sum of 1D array, guys. Okay, so here, this is not only a problem, it's a technique. Okay, so through this problem, we're going to we're going to learn a new concept, a new technique of array data structure. Okay, so there are some few problems we have must learn. You must know these algorithms. Suppose sliding window concepts, Moore's wording algorithms. So it's kind of basic algorithms we're gonna use in our array problems. Okay, so before solving array problems, we have to must know what is a prefix sum technique, what is a sliding window concepts, and what are the Moore's wording algorithms. So right now, we're gonna first understand problem statement. Okay, so through this problem statement, we're gonna solve. Okay, we're going to learn a new technique that is called prefix sum. So the problem statement itself, you're going to see that it's itself, uh, it itself tells what is the prefix sum technique. Also, you can attempt these questions at Leet code. Okay, so what we will do, we will just put that question link in the description box. So first understand the problem statement. So here we have given an noun. Okay, so this is basically nums and array. Okay, so we have given an array nums and we have to define a running sum. This is kind of situations. Okay, what and here we have to define the running sum of an array as running sum of I, like running sum of that index is basically simply sum of their previous elements or their previous numbers. Okay, that is element at index of I at the index of I minus 1, I minus 2 and up to 0. So we have to just return the running sum of nums. That is the problem statement. So also you can understand and better by this example. So think about the situation. So we have given this nums array as 1, 2, 3, 4, and we have to just define, or okay, so we have to return the sum of nums simply. So for that we have to define a running sum. What is that? It is simply sum of their previous numbers of that element. So for the position number first, it is simply 1, guys. Okay, for the position number second, it's at say index 1. Okay, because we always start index with 0. So it is simply the sum of their previous numbers and that number. So that is simply 1 and 2. So we here write 1 plus 2, and that 3 is simply the sum of their previous numbers and that correct value. So it is simply 1 plus 2 plus 3, and same way for 4 it is sum of all the numbers, their previous numbers into that is simply 1 plus 2 plus 3 plus 4. So also you can see that this 3 value, okay, this 3 value we have already calculated at this position. Suppose this is our I index and we have already calculated this number at I minus 1. So we can simply write here, this is our current I value and this sum, that is 1 plus 3 is the sum of I minus of 1 value. Okay, so we're just gonna add those values also directly. Okay, so we will tell you about that. So this is basically our prefix sum array or a running sum array. Okay, so here it simply gives 1, 1 plus 2 it's 3, 1 plus 6 is sorry 1 plus 2 plus 3 is 6 and 1 plus 2 plus 3 plus 4 is 10, and that array is our prefix sum array. You have to understand this. Okay, and this technique we're going to learn this technique by this problem, and there are various application of this problem. It is suppose we have to find equilibrium. Okay, so find equilibrium. This is kind of problem equilibrium. Okay, forget about the u r I u m. Okay, this is not I, this is only u, and we have to just find 0. Okay, somewhere with given sum. We can solve this problem using sliding window concept also. Given sum, 0 sum, or somewhere is sum with size k. So these are basically problems, some problems. Also, there are other problems too. So we can solve these kind of problems using this concept, that is prefix sum technique. Okay, so if you are doing comparative programming and you are learning DSA concepts, so you must know these kind of algorithms to before solving array problems. Okay, so through this problem, we're just gonna learn this technique, prefixing technique. So here, let's see. So it is simply, you can see that prefix sum. Okay, it is simply we can write if we have simply an array as 1, 2, 3, 4. This is basically our array, and our prefix sum array is 1. 1 plus 2 is 3, and 3 plus 3 is simply 6, and 6 plus 4 is 10, and 10. Okay, it is done. So what we basically did here, we simply add. Suppose we have to calculate prefix sum of the value I. So suppose think about this situation, this 6. It is simply sum of, okay, it is simply uh, that their previous sum, because it was already stored there in that prefix sum array. You can name is as a prefix sum. It is simply an array of prefix sum or running sum. Okay, so to this problem, and this is our nums array. So right now here, how can we calculate that value? So it is simply, you can see there, that is basically the previous nums element sum. So here we're gonna simply write prefix sum of I minus of 1, their previous values, and plus the current value, guys, of this. So that is basically a simple concept of prefix sum. But after learning these concepts, we are able to solve the problems, like suppose we have given the range and we have to calculate the sum between that range. Okay, so here in this problem, think about the situation. You want to add these values 2, 3 and 4. So here it is simply, you can say that 3 plus 2 5 plus 4 is equal to 9. Okay, so how can we solve this problem? Suppose we have given a lot of ranges and the array size is 100. So there we have to use this technique. So suppose we have given a left index and a right index. Okay, so in this kind, like in this example, we have taken like 2, 3 and 4. So what is the value of L simply? So this is basically 1. Okay, this is 1 and this is 3. So for this example of, okay, so at this array, simply we can understand that I'm just gonna use this concept L. L is simply 1 and R is basically it's n minus of 1, it's 3. Okay, and how can we get the value 9 by using this? We can see that if we subtract the value 1 from the value 10, so it gives you simply 9. Okay, and what is that value, guys? So here, 1 minute. Okay, what is that value? So this 10 is simply the value at index R. Okay, so here what is R? R is 3. So it is simply prefix sum, and this is value 3, and simply the value R. You can just generalize it as R minus, and this value is 1, guys. Okay, but you can see that what is the value at index 1? It is simply 3, but we are using 1 here. Why? So it is simply prefix sum, and that means L minus of 1. Okay, so I'm just generalize this, but you have to just write here 1 minute. Okay, so you have to just write here 0. When we're gonna generalize it, it is simply give us that is. Okay, I'm just using another pen. I'm just gonna use another pen to generalize it. So it is simply prefix sum of R minus prefix sum of L minus of 1 if you want to calculate the sum between the range. Okay, so why we gonna learn this concept, the prefix sum technique, and when we're gonna solve some problems on these techniques, we're gonna use this concept that if you want to find the sum between the range, we have to just write the right index and minus of and minus of 1. So are you gonna ask me gonna why this equals to from like if you gonna add 2 plus 3 is equal plus 4, that gives you a 9. And why this is equal as to 10 minus of 1? So simply think here in this array. Okay, so suppose we want to get 3. How can we get that? We simply add these values. That is 1 plus 2 gives 4. Okay, so this is not 3. Suppose this 3. What is that? This 3. It is simply a 1 plus 2. Sum between that value. Okay, and we want to get 10. This 10. And it is simply a sum of 1 plus of 2 plus of 3 plus of 4. Okay, and here suppose you want to get the value, which value like sum. So if you want to calculate the sum 2 and 4, that means sum up to 2 is simply 3. Okay, and the sum up to 4 is it's simply 10. Okay, so here it is when you're gonna see that when you subtract these values. Okay, so here it is simply 10 is 1 plus 2 plus 3 plus 4, and 6 is simply 1 plus 2, that's 3, and our next value is simply 1 plus 2 plus 3. So suppose if we subtract uh, those values, suppose so here 2 3 4, but total sum is basically uh, 4 plus 3 is 7, 2 9 10, simply it is 10. So if we subtract the value 1 from 10, we can get this all values. So why? So why this? We just use the array in this way that are okay. The right index, the right part, is simply we consider as the last index. Suppose you sum all the numbers, and if you subtract this value, you can get the remaining sum. Same way here. So why we just subtract the value 1 from this value 10. Okay, and it simply gives the sum from 1 to 3, 4. So because why? Because we already sum all the numbers at that index, at the last index. That at the last index means we already sum all the numbers. And if you add the first index, that means you did not sum any value. Okay. And if here the range is, suppose we want to just add 3 and 4. So in that kind of situation, we have to consider this part. So that is basically our prefix sum technique. Okay, and I'm just gonna update this as prefix sum technique. Just understand this concept. So this problem should not be that long. Okay, it is very simple. But here we have learned a concept prefix sum technique. Also, we learn another application of prefixum technique. So when you will solve some problems on prefixum technique, you will understand how can we use this technique. Okay, so it is simply prefixum of minus of I, should be minus of I. Okay, 1 minute. Prefixum of I, okay, is equal to, simply equal to prefixum I minus of 1 plus nums. I think why it is erased. Okay, so don't worry about that. So this is basically our first formula for prefixum, and this is for second. Now let's come to our question. Okay, so this is our problem, and here what we will do, we're going to solve this problem at Leet code. Okay, and there you will see how can we solve this problem. So we just simply add all the previous numbers. So here, okay, so here what we basically do, we just add nums of I with that value and their previous value, and it will simply update. Okay, this is simply nums of I is equal to nums of I minus of 1. So here we are not using another prefix sum array, we just simply update that array with the concept. Okay, and we just simply return nums. You can also use another array, but it's kind of waste of time. So why we use the same concept at nums of I minus of 1, it's simply their previous value, and again the current value is nums of I. Okay, so here I mean just gonna run this program. You will see it takes like 0 time, and it's 100% faster. So this question is like very simple, but the concept is very important. So why I use just 16 or 15 minutes to solve this problem. Hope you understand the concept, prefix some technique, and if you like the video on editor structures, and so you can just do subscribe the channel right now.